Hello everyone, I am Minakshi, working as an Assistant Professor, IT Department, KIET Group of Institution. In this lecture, I will be discussing about 8086 memory interface. In this topic, I will be discussing about memory organization in 8086 microprocessor. So let's get started. So how memory is organized in 8086 microprocessor? In 8086, memory is viewed as an array of 8-bit bytes, contiguous array of bytes. 8086 microprocessor supports 1 MB memory. And 1 MB memory is organized as an array of bytes. And in memory, we can store instruction, byte data, and word data. Byte data, a 1 byte of data, word data, as 8086 microprocessor is 16-bit processor, so word length is 16-bit. So word will have 2 bytes of data. And instruction, byte data, and word data can be stored anywhere in the memory. 8086 can access any 2 consecutive bytes as it has 16-bit data bus. So it can access 2 bytes of data. Lower address byte is the least significant byte of the word and the higher address byte is the most significant byte. So 2 byte data will be like lower byte data and higher byte data. This will be least significant byte and this will be the most significant byte of the data. And here we can store instruction, word data, byte data in the memory. How memory is organized? So 8086 has 16-bit data bus and it must be able to write data to 16-bit location or any 8-bit location. And 16-bit data bus is divided into 2 separate sections or banks. So here you can see D0 to D7 and D8 to D15. The data buses are divided into 2 parts. And microprocessor 8086 can write to either half 8-bit data or 2 halves 16-bit data. It can write 16-bit data at once or it can write 8-bit data in both of the banks. So memory is organized into 8-bit banks, lower bank and higher bank. So all the even addresses make lower bank of the memory and all the odd addresses make the higher bank of the memory. 8086 microprocessor supports 1 MB memory. So this 1 MB memory will be divided into 2 512 KB bytes. So high bank will have 512 KB and lower bank will have another 512 KB of memory. So lower bank of memory contain all even addresses and high bank of memory contains all odd addresses. So address 0, address 2, address 4 in even addresses and address 1, address 3 and address 5 in odd addresses set. Here 8086 microprocessor uses signal VHE bar to select high bank and address pin A0 to select low bank. So here VHE bar is selecting higher bank or we can say odd bank and address A0 is selecting lower bank, or we can say even address bank. And these two signals can select both the banks of memory simultaneously. So in this table, we define how BHE bar and A0 will select the banks of the memory. So 0-0 combination for BHE bar and A0 will select both the banks. 0 will select a high bank and 0 will select the low bank, because these are active low selection pins, and 0 value will select the bank. Here BHE bar is 0, so it will select to the high bank, but A0 is 1, so it will not select the low bank. BHE bar is 1, so high bank will not get selected, and A0 is 0, so low bank will get selected. BHE bar is 1 and A0 is also 1, so no bank will be selected. So in this way, 8086 microprocessor select banks of the memory. Bank selection is done in two ways. So what is the technique to select banks of the memory? One is separate write signal. And another method is to use separate decoders. So in second method, separate decoders will be used for both banks. A decoder for high bank, a decoder for low bank. So both two decoders will be used to select the memory banks. In first method, a write signal will be combined with VHE var and A0 to select the bank. Here separate bank write stroke. First method. Here write signal will be combined with VHE bar and A0 bar with the help of OR gates to generate high write bar and low write bar. High write bar will select high bank and low write bar will select low bank. So in this way, the write signal can be used to select bank. This technique require only one decoder, because we are using write signal to select banks. Only one decoder will be used to decode the addresses. Whereas in separate decoders, two decoders will be used for separate banks. Aligned versus unaligned. Whenever a data will be stored in memory, here the aligned and unaligned storage concept comes into the picture. If word of data, it means 2 bytes of data is stored from the even address, then the data will be called as aligned. We have high bank and low bank, and we have even address in the low bank and odd address in the high bank. If the lower byte is stored in the even address and the higher byte is stored in the odd address, then the word will be called as aligned word. Here in this picture, you can see that the word is stored from the even address to the odd address. So word is stored at even address. Then this word is aligned word. But if the word is stored from the odd address, here the lower byte will be at odd address and the higher byte will be at even address, then this word will be misaligned word, or we can say unaligned word. So data can be stored in the memory starting from the even address or starting from the odd address. Whenever the word is stored from the even address, the word will be called as aligned word. And a single read cycle will be used to access that word. If the word of data is stored at odd address, then the word will be called as misaligned word. And it will require 2 read cycles to access that word. So to access unaligned word, the processor will require 2 read cycles. In first read cycle, the odd address will be read. The data from odd bank will be placed on higher buses. And in the second read, the data from the even address will be placed on data buses D0 to D7. Suppose that data is stored from address 3. So its lower byte will be at address 3 and the higher byte will be at address 4. So first the data from higher bank will be placed on higher data buses and then the higher byte of data will be placed on the lower buses. So it will require 2 read cycle to access this word. So whenever unaligned word is stored from the odd address, the microprocessor will require 2 read cycle to read that unaligned word. These are the references for this lecture. And in this lecture, we discussed about the memory organization. Memory in 8086 is organized in banks, higher bank and lower bank. Lower bank is the collection of all the even addresses and higher bank is the collection of all the odd addresses. And then we discussed about the aligned and unaligned word concept. Thank you very much. Happy learning.